Welcome to the course Wireless Networking and Mobile Computing. So this is the session 1. In this session we will be discussing introduction to the course. So after completing the session 1, the students will be able to understand like how future computers will look like and what is the difference between user mobility and device portability. What is mobility and what is meant by portability, and then you'll be able to characterize the various devices. You'll be able to understand the characteristics of various wired, wireless, and mobile devices. And then you'll be able to describe several applications of mobile communications. And also you'll be knowing the history of wireless communication. So this is the objective of this particular session. So let us start with the introductory session. So first let us try to understand how the future computers will look like. So from past, if you see, originally in 1960s, when the computers were introduced, they were huge machines which occupies a big room. And after 1970s, in late 1970s and 80s, personal computers were introduced. Still, they are bigger in size. And day by day, we can see that because of Moore's law and other technologies, the size of the computer is getting uh, reduced and its performance is increasing. So, so what we can understand in the sense, the future computers will be more portable and surely it will communicate using wireless technology, and embedded systems or embedded technology will play a crucial role. That is the entire system will be integrated. It will be like a uh, like the system as a single unit. We may not be having multiple devices which are interconnected to the computer, and every device may have some processing element on it. So in today's scenario also, if we see, if you purchase a washing machine, if you purchase a refrigerator, if you purchase a smart TV, all these devices do have a processing element, or or either or a controller, or we call it as a device controller. So these devices have a device controller, which are nothing but processors. So like this, in future, every device may have a processor, even a small device, whatever we use, maybe the chair, the bed, the table, all the day-to-day things that we are using, the pen, mm, everything may have a processing element in it, because because due to the advent of sensor technology, the the cost of the hardware is getting reduced day by day. So internet of thing may soon merge into internet of everything. And in future, the aircraft may provide internet access to its customers. So today's aircraft provides limited network services. So you can understand the aircraft is something which travels at a speed of 700 to 900 kilometers per hour. So if internet is to be provided at that speed, then we need a network which is working at that particular speed. Similarly, the cars or vehicles in the future will have internet access. So today's vehicles do have internet access to a certain extent. So that is the cars will be able to communicate with with the neighboring cars, and they'll be understanding the traffic pattern, and if there is any accident, that will be communicated to the cars which are coming in the back, so that they can slow down. And also the cars would be able to identify and communicate with the devices that are present inside the car, and they may form a local piconet kind of network, and these devices like mobile phones, laptops, or personal digital assistants, all these devices would be able to interact with each other. So this is how the future computers uh, will, will probably look like. So now let us try to understand the difference between user mobility and device portability. So when we say user mobility, it means that the user is moving. The user is moving from one place to another place, but whatever the wireless services he is he is availing in his original place, the services follows the user. The services follows the user irrespective of where he is. So that feature is called as user ability. So for example, we can consider call forwarding technique. Say currently you are in one country, and maybe after sometimes you may move to some other country, and still people can access to you through that same particular mobile number, because the service is following you, so your network service provider will understand where you are currently located, and accordingly the call will get automatically traveled, automatically will get transferred to that particular location. So that feature is called as call forwarding. And similarly, computers, for example, you may log in to a computer at different places, but you will have a similar appearance of the desktop, because you will be logging in with your user ID and password. So whether you log in your home, or whether you log in your office, or whether you log in elsewhere, the interface or the desktop that you are going to experience will be similar, uh, irrespective of the place or time. So here, in spite of the user is in spite of the user is moving, the service is following him. So that is called as user mobility. And coming to device portability in the sense, here the device moves. Here the device moves, and even though the device moves, the device will be able to communicate. That is, the device will be able to adapt to the network that is available wherever it moves. For example, in your home, your device may be connected to the internet through a broadband network. But when you go to your office, or when you are traveling, maybe the device may get connected to the internet through some other technology like Wi-Fi, or anything else. Okay, so basically, even though the device moves, it adapt with the environment, and in that environment, whatever the network available, the device will be able to communicate with that network, and it will be able to avail the internet and other services. So one example is the mobile phone switching from one base station to another. Say for example, you are in a location where your signal is getting very low, then automatically your mobile phone will switch off, will switch from this base station to some other base station. So in that case, when the device moves, it is able to still communicate, because it adapts with that particular environment. So this is the difference between user mobility and device portability. With user mobility, the user moves and the service follows him. And with device portability, the device moves and it adapts to the environment, and in the environment whatever the network available, it connects with that particular environment, and it continues to provide its whatever the service it is supposed to provide. The next thing we'll be discussing is characteristics of various communication devices. Okay, so under this, so so the communication device can be characterized into four categories. These are fixed and wired, mobile and wired, fixed and wireless, and mobile and wireless. So let us try to understand what all these things are. So fixed and wired is nothing but a conventional technology where you have a fixed computer, you have a personal computer, and that is connected to the network or internet through a wired communication, maybe through a LAN or a WAN or or any other technology. Using that, it is connected to your network, or it is connected to the internet, maybe through through some wired medium. Okay? So such a network is called as fixed and wired network. So these networks probably the size of the device, the size of the computer will be huge, and its weight also will be high. So basically these are not portable. So these are not mobile. You cannot carry it anywhere. So they are fixed, and also they avail wired services. So so such devices comes under fixed and wired category. The next thing we have mobile and wired. That is, the device is movable. Mobile in the sense the device is movable, but still it uses a wired communication. So a good example for this is laptop. So laptop falls in this category. So for example, user carries laptop from one place to another place, and in that place, whatever the network available, they may connect to that network through telephone network or a modem, or through some means they will plug into that network. Okay. So for example, in the home, I may connect my laptop with my uh, broadband internet. If I go to the office, I may connect with the office wired internet, wired LAN, okay, through which I will be getting internet. So in this case, the device is movable, but still it uses wired connectivity for communication. So so such devices comes under mobile and wired. And the third category is fixed and wireless. That is, the devices are fixed. Here the devices are not going to move. They are fixed in one place. But still we are not going for wired option. We are going for wireless option. The reason is, maybe for example, it may be a historical building. It may be a historical building, and in that historical building, probably you may be installing some CCTV cameras, or and some what you call some displays to see the people at different places. So we need technology, but still we don't want to use wires, because wires are cumbersome, and you may have to break the walls and other things which you don't want to do. So in that case, the devices will be fixed, but the devices will communicate using an wireless media. So 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 such devices comes under fixed and wireless. And the fourth one is mobile and wireless. So this is uh, the most interesting thing. So here the device is movable, and also it is wireless. There is no wire. The device is movable, and it communicates using wireless networks. So all the mobile phones, uh, the gadgets like mobile phones, all these things comes under in this category, mobile and wireless. So this is how the wireless networks are characterized. Fine. So the next thing we'll be discussing is applications of mobile communication or wireless networks. So we'll be discussing, so there are plenty of applications, but to name a few, we'll be discussing these applications, some of these applications under these headings. So in vehicles, that is in cars, in flight, in what do you call, in cars, in flight, in trains, in trucks, how wireless communication is helpful. That we'll be discussing under vehicles. And then under emergency situation, how wireless communication will be useful, and what the role it plays. That we'll be discussing under the heading emergencies. Then uh, for from business perspective, how wireless communication will be useful. That we'll be discussing under the heading business. And replacement of wired networks. So what are the places where wired networks can be replaced with wireless networks? And then we'll be discussing infotainment and more. That is how the wireless networks helps us to uh, get the information, latest information, or 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 in what way uh, it provides entertainment to the customers. So that we'll be discussing under infotainment and more. So these are also some of the applications of uh, wireless communication. Then we'll be discussing the various location dependent services provided by wireless network and mobile communication. And at last, we'll be discussing the different types of mobile and wireless devices that are currently available. So we'll be discussing applications under these headings. Fine. So let us start with vehicles. So if you so coming to vehicles, so so the vehicles may use the future vehicles may use a digital audio broadcasting technique DAB to get the details about news, road conditions, weather report, and for listening to musics. And this technology will work at a speed of 1.5 megabits per second. And inside the vehicles, the customer may use UMTS or GSM for personal communication. So UMTS stands for Universal Mobile Telecommunication System, and GSM stands for Global System for Mobile Communication. And for remote communication, the vehicles may use satellite communication. So if they are in some remote location, or the vehicle want to communicate to some remote location, then GSM can be used. And GPS is helpful to understand to know the position, to know the current position eh, of the car. Okay. So and also cars would be able to communicate with each other by using a technology called VANET, vehicular ad hoc networks, where different vehicles which are traveling in the road, they will be able to communicate with each other, and they will be able to exchange the traffic patterns. And also by that, the vehicle will understand which route is having lesser traffic and which route is having more traffic, and which route they should take. And also if there is any accident, uh, so whenever there is an accident, the airbag will trigger. But other than getting the airbag triggered, the vehicle which involved in the accident will also transmit this information to the vehicles which are coming at the back, so that they will slow down, and and further accidents can be avoided. So so these are some of the typical applications of wireless networks in for vehicles. And also today, nowadays itself, buses, trucks, and trains, they are transmitting maintenance and logistic information to the base station. So in future, uh, these devices will be able to perform, uh, will be able to provide much better services also. And if you consider air travel or train travel, so actually as of now, internet services are not available for the customers who are traveling in flight, because flight travels at a speed of 700 to 900 kilometers per hour, and the current trains travel maximum at a speed of 350 kilometer per hour. Okay, but many technologies cannot operate at this speed. Most of the wireless technologies what we have today uh, cannot operate at this particular speed. Okay, for example, GSM can operate at a speed of 250 kilometer per hour. So its maximum speed is only 250 kilometer per hour, but flight is traveling at a speed of 900 kilometer per hour. Okay, and the fastest train in the world is traveling at a speed of 350 kilometer per hour. Okay, but the current speed of GSM is 250 kilometer per hour. Okay, so 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 this is quite challenging. So we can expect that in future these communications are available for air travel and train travel. Okay. So here is an example. This diagram shows how wireless communication can be used for road traffic uh, monitoring, okay, or road traffic management. So here you can see there are different types of networks like UMTS, WLAN, LTE, GSM, CDMA, Tetra. Like this, LTE stands for long term evaluation. So GSM is also a part of LTE. Okay. So like that, there are different types of networks. See, there is a satellite network, there is a server. So there are some computers which is transmitting information. So like informations were collected from different sources and it is passed on to the vehicles depending on their need. Maybe, for example, the passenger in this car is interested about weather forecast. So he'll be getting information from this particular satellite. Whereas some other passenger may be interested in cricket score and he may be getting the data from this particular server. Like the different customers may be interested with different type of information and that will be provided by the appropriate network. So all these different kinds of network should be integrated. And these vehicles, as already discussed, these vehicles will communicate with each other. That is, they form a network, and that network is called as VANET, vehicular ad hoc network. So if there is any accident, so that information will be passed to the cars which is coming at the back, so that they can slow down and further accidents can be avoided. Okay, and also the devices which are inside these cars. For example, the passengers who are traveling in this car may have different devices. Like they may have a basic cell phone, they may have a laptop, they may have a iPad, and all these devices would be able to communicate with each other by forming a piconet. Piconet means maximum it can have 8 devices connected to it. So by forming a piconet, these devices would be able to communicate with each other. So this is how mobile communications are are used for vehicles. Next, let us understand what is the application of mobile communication under emergency situation. Okay, so let us imagine the possibility of having an ambulance with high quality wireless communication. So then what happens in the sense, when the person is traveling, when the person who met with an accident is traveling in the ambulance, during that time itself, vital information about the injured person can be sent to the accident, can be sent to the doctor or to the hospital from the scene of the accident, from the accident spot. It is the vital information about the patient can be transmitted or sent to the doctor, while the passenger is uh, while the person who met with the accident is just traveling in the ambulance, and so that the appropriate specialist doctor can be consulted, and all the diagnostic procedures can be kept ready well in advance, and the best service can be offered for the one who got affected. Okay, so this is one of the use case where wireless or mobile communication a, can play a crucial role. Okay. Similarly, 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 if there is any natural disaster, if there is any natural disasters, then wireless networks is the only means for communication. Because whenever there is a natural disaster, the wired network will fail, and the mobile network also will fail. The cellular network also will fail, because if the tower or the base station gets affected, then the mobile phones would not be able to communicate with each other. So in such case, we have only one option, which is wireless networks. And the worst case scenario is, if there is, see, here the worst case in the sense, assume the disaster is very high, that everything, no telephone networks are not working. That means any wired network is not working, and cell phone is also not working. So that is called as worst case scenario. So in worst case scenario, only decentralized network like wireless ad hoc network will work, because ad hoc means uh, it is not a centralized network, it is a decentralized network. There is nothing like a boss and slave relationship. All the devices will be treated equally. So such an environment is called as an ad hoc environment. Okay. But the but actually it's a really challenging thing to create an ad hoc network in place of the existing cellular network, because the existing cellular network, all communication happens through the base station. Whereas in an ad hoc network, we will not be having any permanent base station. Okay, the base station will be shifted from one customer to uh, one consumer to another consumer. That is, every device itself, by itself, it may act like a base station. For example, you may have some 6 to 7 devices connected here as an ad hoc network. Currently, one of the device will be acting like a base station, and after some times, if that person leaves this room, then some other device will act as a base station. So 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 the, so there is no fixed base station. Okay, and these are the only networks which will survive when there is a natural disaster. Okay, so this is how the mobile communication can be useful under emergency situation. And then the application of mobile communication in business domain. Let us consider a traveling salesman who needs instant access to company's database, but he is keep on traveling. So how can he get the instant information? So he can get the instant information uh, probably through mobile communication, and that is whenever there is a change in the database, that he can observe the change, and he can be informed about that through laptop or through any other mobile communication system. uh, but this system also you should make sure that it provides good, efficient and powerful synchronization mechanisms, so that there is no data consistency issues. So let us try to understand how mobile communication will be useful uh, for a traveling salesman. Okay. So, this traveling salesman, let us understand, he is traveling from his home and he is going to different locations. So when he is going from different locations, he may have to pass through different network. So his device, which may be a mobile phone or PDA or laptop, it will switch from one network to another network. Maybe in the home, he will be using DSL or WLAN or uh, or any other broadband connectivity to connect to the internet. Okay. The moment he comes out of the home, then this DSL network is not available. It means his device should be connected with some other network. So maybe in the outside GSM edge, this type of network may be available, and the device will be connected with that network. Okay, and then he goes to the gas station for filling gas. Maybe the gas station may provide some service like GSM or WLAN service which the customer can avail. And then probably he may take a train and he is going from one city to another city. So the train in the train also he may get internet services through uh, through technologies like LTE, long term evolution. Okay, and finally he reaches his office. So in his office probably he will be connected to the internet through a high speed LAN or a high speed WLAN. Okay. So basically this shows the role of mobile communication at different places, at different walks of life, and how the device is handing over itself from one network to another network. So that's what so that is how uh, mobile communications are applied in business domain. Okay, so next let us discuss the replacement of wired networks. Okay. So in some cases wireless networks can be used can be replaced with wired networks. Some in some places wireless networks uh, I mean, sorry, in some places, wired networks can be replaced with wireless networks. Example in historic building. So in historic building, we don't want many cables, and also we don't want to put holes on the walls and all those things. So wireless network is the most preferred technology there. That is, the devices will be fixed, but they will communicate using wireless technology. Similarly, there are many other applications where, due to economic reasons, wired communication is not possible. For example, if you take weather forecast, if you take mm, weather forecast, earthquake detection, or any other application which provides information about the environment, in all such cases, wired network may not be a preferable solution, and also cost wise, economically also they may not be feasible. But in such cases, mobile communication would be very much helpful, and it comes handy for these type of applications. Okay. So 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 this is how mobile communications where you can be used to replace the fixed wired networks. So in most of these cases, for example, for weather forecast, earthquake detection, and environmental information, for most of these cases, satellite communication might be the proper tool or the proper mode of communication. Okay. Especially if you want to forecast the weather, or if you want to detect earthquake, or if you want to know the area which I mean the type of the land in different areas. Okay, so all these informations can be better captured using satellite networks. Fine. The next application of mobile communication is infotainment and more. That is, so of course, mobile communication provides a lot of entertainment and also a lot of up to date information. That is, you can get the news, in any language, whatever you prefer, and whatever the games or online games that you want, you can play. So so mobile communication uh, is also applied in this area. The next is location dependent service. So location dependent service means depending on the location, the user may need different types of service. For example, uh, the first category that we'll be discussing under location dependent services is follow on services. So the example for follow on services include automatic call forwarding and having similar desktop appearance at different locations. That is that is when you move from one place to another place, or one city to another city, or one country to another country, automatically your call will be forwarded to wherever you are. Okay? Because because your details are registered in the mobile station. I mean the mobile base station, and whenever a call comes, the base station will know where you are currently located, and there the call will be forwarded. So that type of service is called as follow-on services. Similarly, you may have the similar or same kind of desktop in spite of whether you log in from your home or you log in from your office. So, so these are the examples for follow-on services. That is when the user moves, the service follows him. Okay. The next is location-aware services. Say for example, you are currently sitting in a hotel or somewhere outside, and 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 you are printing something through your computer, and you are printing something through your laptop. Okay, in your laptop there is a print icon, and you are just dropping a file there, which means it should be printed. Okay. Now, where you expect this particular file to be printed? Should it be printed in your office printer, or should it be printed in the printer in the hotel where you are staying? So obviously you don't want to print it in the office printer, because currently you are in the hotel. So you want the file to be printed in the local system. Okay. So you want the file to be printed in the in the current location, or if there is any printer, you are sitting in the hotel. So in this hotel, if there is a printer, you want the print to be printed through that printer. So that is what you are expecting. Okay. So location dependent services, what it do in the sense, it will identify the devices that are located near to it, and maybe if there is a printer in the hotel, then it will automatically connect to that printer, and whenever you give, the file will be printed from this particular printer. Okay, which is closest to you. So so this type of services which are provided by mobile communication systems are called as uh, location dependent uh, or location aware services. Okay, so we are discussing this under location dependent services. So first we discuss follow on services, and then location aware services. That is, this printer example is an example for location aware services. But all these services like follow on services, location aware services, all these have privacy issues. That is, it is not that everybody can access our location. So generally we don't want everybody to access our location. So we have some control or limit on that. Okay. So depending on the users you trust, so for them we'll share the information. For others, typically the consumers will not share the information. Okay. So follow on services, location aware services, all these has lot of advantages, but the disadvantages, it has the privacy uh, issues in that. The next is information services. So these information services can be classified into two categories. One is called as push service, the other one is called as pull service. Push service means You as a user, you will be asking the communication, I mean the mobile communication system, like where this particular service is available. Example, you may ask where South Indian food is available. What is the nearest hotel where South Indian food is available? Then your mobile phone may provide that address, and it may provide you the route map for that. Okay, so that is an exam. So whatever the thing now I said, that is an example for pull service. That is an example for pull service. Pull service means the user request. The user request, and the mobile communication system accordingly responds with a service that is called as pull service. Push service means the user does not request anything, but the mobile communication system provides some suggestions. Say for example, when you are traveling by a car, you may get a message stating that don't take this particular route, rather take some other route because there is less traffic in that route. That is an example for push service, because you are not doing anything, but still you are getting some information. Or when you are passing through a road, it may say that here there is a what do you call, here there is an internet cafe, which means it is a push service, because you have not asked, but still the system is giving you some input, so that if you want, you may use or you may not use. Okay? So basically, push service or the advertisement messages which are sent by the uh, internet service provider or mobile service provider to the concerned devices. Okay, whereas pull services are the request made by the user or the customer, that I want so and so, and the mobile communication system will respond with an answer, like where it will be available, where that service will be, from where that service can be availed. Okay, so this is about the information services. So that's it about location dependent services. So next we'll discuss the various mobile and wireless devices that are used. So this list is not exhaustive, and the list will keep on change, because due to the fast pace at which the technology is growing, uh, and there is no clear separation between these devices. Okay, so it's a broad classification of various mobile and wireless devices. So the performance of the devices increase in this order. Okay, that is, the device which is towards the right has more performance than the device which are in the left. Okay, so first we have smart dust. Smart dust, in the sense, it's a very small electronic particle which can probably sense various parameters from the environment, like heat, light, temperature, and that may be passed through a nearest server. Okay. Next, we have sensor embedded controllers. So these are basically embedded controllers which are used to control different devices. For example, nowadays, if you take any device that comes with an controller, for example, washing machine comes with a controller, smart TV comes with a controller. So any device that you purchase will have a controller. So 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 any device that you are using in your day-to-day life can also be treated as a mobile or a wireless device if it don't use any wires. And then we have the basic cell phone. The basic cell phone, the classical mobile phone, which provides uh, basically the voice and a very limited amount of data services. Okay, so that also comes under mobile and wireless device. And then we have PDAs, personal digital assistants, with graphical display and with the feature of character recognition. Okay. So these are the personal digital assistants are not laptop. So these are more robust devices. Normally, these devices will be used by the firefighters, because once they enter the particular place where there is a fire, then they cannot carry the normal laptop, because normal laptop may not be withstanding that heat. So they carry this special type of laptop which is called as PDAs, a personal digital assistant, and here they can store different kind of informations. And then and then we have smartphone or tablet. So smartphone or tablet, that is that you know what are the features it has. So through a smartphone you can make a call, and also you may have plenty of applications which provides you a lot of informations about the various things. And at last we have the laptop or a fully functional standard computer. So the performance of these all these devices increase in this order, okay, and the size decreases in this order. Right? So so that's it about mobile and wireless. I mean the applications of mobile communication systems. So so let us stop here. In the next video, let us discuss about the history of wireless communication. Okay, thank you.